Hi, everybody. It is Sun Week this week, and we have our very own star. Isn't it wonderful? And we're going to talk about the layers of the sun, different properties of the sun, and we're going to look at a live telescope online that lets us peek at the sun in real time. So how fabulous is that? Let's go over to Canvas, see what we've got ahead of ourselves. We're going to talk a little bit about the sun and the solar system. We have our study guide. Please remember that is your second instructor, is your textbook. We're going to go through the layers of the sun. Each layer is different and unique and radiates heat outward from the center of the sun where nuclear fusion occurs outward to the light in the photosphere that you and I see. We're going to talk a lot about sunspots and the solar activity cycle. And then we're going to do our lab. Of course, we have our constellations this week and our quiz. So let's go on over to our lab for the week. Our lab this week is going to be varied and diverse and lots of fun things. So one of the things we're going to look at is the solar activity cycle. Our sun has, for hundreds of years, been observed going through activities where it has a lot of different sunspots and then few sunspots. So one of the things I'm going to ask you to do in lab is look at real live data. These are the years starting in 1750, a while ago, and this is number of observed sunspots that year. And you'll see that there is definitely a pattern. Lots of sunspots, few, lots, few, lots, few. And each one of these solar cycles has been given a number, cycle 0, 1, 2, 3, and so on. And these solar activity cycles continue through the modern age. I want you to look at this data, analyze this data, and answer a whole bunch of questions about it. And that is, a lot of those questions are on that first page. Now, besides looking at that solar activity data, I want you to look at this chart. This chart is aggregate or total sunspot number for the years, and these have been counted since back in the 1600s. Total number of sunspots over time, year by year by year. And that activity cycle, you can definitely see there was a huge gap from over 50 years, from the mid 1600s to the early 1700s, and it's referred to as the Maunder minimum. Lots of different thoughts and ideas about what caused that, and then the effect that that had on planet Earth. We talked about that, or we'll talk about that in notes, but I want you to relate that information with years of global temperature and see if you can come up with some correlations between the two. You're also going to look at things called butterfly diagrams, and they're butterfly diagrams. They're called that, as you can see, because they look like a collection of beautiful butterflies, but they relate to the latitude of sunspots, where they're found on the sun, and how those vary over time. When sunspots appear, they tend to be at relatively high latitudes. If this is the solar equator, right in the middle or the tummy of the sun, when sunspots appear, they tend to appear at high or low latitudes, high latitudes, high north and south latitudes. And then as the solar cycle continues, they get lower and lower and lower. They disappear, boop, and then when they pop up again, they pop up high. So I want you to look at this data, compare this to these solar activity charts down here, and answer some questions. These are good scientific skills. Can you see trends? Can you correlate one set of scientific data with another trend? And these are fascinating because this is real information about our star. This is kind of a fun collection of pictures. This is the location of sunspots and how they have changed through time. I was happy to find this image through time, how the sunspots have changed latitude from one location to another to another. This is a fun one because this is an indicator of how the sun's magnetic field changes with time. So we have when there are few sunspots, the sun's magnetic field tends to look like this, straight up and down like a little bar magnet. And as we get more sunspots, the sun's magnetic field gets kind of twisted left and right. As the sunspot number goes up and up and up, it turns very much on its side. And when the sunspot number drops again, it goes boop, up and down again. Interesting stuff. One of the ways that we know the rate or speed at which the sun rotates on its axis, because the sun does rotate on its axis just like the Earth, is by looking at how fast one sunspot will travel across the sun. So take a look at these dates and fill that part in. I want you to watch this short little 2-minute YouTube video to explain the difference between a CME, coronal mass ejection, and a solar flare. Many people who do not understand the differences use the terms they intermix them, and they are not the same. Flares are light, CMEs are matter. They are particles, and they travel at very different speeds. And here's the very best part. You're going to copy and paste this into any of our browsers, and then you are going to go to the Solar and Heliospheric Atmospheric Observatory, or SOHO, and you are then going to go to space weather. And space weather is where you get to see live images of our star. So on the date that I'm making this video, these are the very latest images of our sun. This is a solar observatory in orbit up in space that's sole purpose is to look at our star. You can look at it through various filters. If you want to see it in just the photosphere, right now it's not very exciting because at the moment I'm making this video, we're in the middle of a solar minimum, very few sunspots, and so it looks very yellow, very, very yellow. But you can go back and you can look at our sun in the magnetic field, and in the magnetic field you can start to see some activity magnetically that you could not see in the visible light. So what I'm going to ask you to do when you go to that space weather telescope is I want you to look at each one of those images and record and color and draw what you see. Now, if you, on the day and time you look at the solar telescope, happen to see a big yellow dot like I saw one, please don't just leave this blank. If it looks yellow and there is no sunspots to be seen, then there are no sunspots. So please indicate that. If you can find plages, remember that is what looks like that white beach sand, indicate those plages on this image. I want you to look at the magnetogram. The magnetogram is that black and white image. And knowing what you know about the direction of magnetic fields and high magnetic field, high sunspot numbers and low sunspot numbers, see if you can tell what the direction of the magnetic field is and sketch that in. Use it as a multiple choice thing. It's either going to look like this or this or this, and that's what you're looking for. And if you know there's a low sunspot numbers, then you're going to be aiming towards here. If you know there's lots of sunspots here, you're aiming closer to here. And if you're somewhere in between, you're probably somewhere in between. You're looking for something that looks like straight tiger stripes or left and righty sided tiger stripes. But this is the magnetic field of our star. For this one, I want you to look under different filters. We can see our star under a variety of different filters, from blues and greens, and each one of these is going to show us different things. Now, I want you to use these different filters to help identify coronal holes. See those pretty little spicules on the outside edge? Those are those little spiky bits. Here is a little CME occurring right here. Again, little spicules. There's some cold spots on the sun. And if you go to different wavelengths, you are going to see different things. Here is a little coronal mass ejection. Here you can see a hot spot. That's probably a sunspot that just has not erupted yet, like a little pimple that hasn't erupted yet on the sun. So use those different images, label what you can, label all of these on our image. Last but not least, I want you to go to the best images of the SOHO LASCO telescope. Now, the Soho-Lasco telescope, when you go to those, it is going to, if you go to one of these, and I think I actually have this in, there it is. The Soho-Lasco images, nope, that's not the one I want. Hold on, ladies and gentlemen. The Soho-Lasco images, this is like a faraway image of what's going on with the sun. Each one of these is a full picture. The disc right here is covering up the sun, and we get to see what's around it. Because the sun is so bright, unless you cover that up in the photograph, you can't see the surroundings. And what's really, really cool is sometimes in these pictures you get really lucky, and I got lucky today making this video. You know what that is right there? That's planet Mercury. Mercury is in the camera frame, and as it goes around the sun, we actually captured it today on the video. You don't always get it. Matter of fact, seldom do I get it, which is pretty nifty. Now, if you go to the blue camera, this is a slightly different camera angle. You don't see Mercury. It's just a different camera angle, and Mercury is not showing up. In the lab itself, I want you to go to Live Sun Videos, go here, and this is what I want to show you. I'm going to hit play, a video of a video. How wacky is that? But see this going across there? That is something in orbit around the sun. What is that little thing? I don't know. That could be one of NASA's telescopes that's orbiting the sun. That could be a comet. And here comes Mercury. Whee! There comes Mercury. Ain't that cool? And at the moment I'm making that video, this is what's going on with our star. So pretty great stuff. Back to the lab, fill in the blanks. I want you to either, when you're looking at the sun, use this website, or I highly recommend that you use some sort of an astronomy app to try and figure out what is near the sun. Sometimes you find a comet, sometimes you find a planet, and see if you can figure out what's near the sun on that date or time. Take a look at the pictures here. Can you identify what's going on? Then I have a couple YouTube videos because I want you to see some really cool filaments and prominences, and I want you to see these videos in real time and identify them, and I want you to see a comet flying by the sun. Can you tell that I am like crazy excited about all the stuff that goes around the sun? Yeah, it's fun. It's really, really fun stuff. So have a good time with it, and we'll talk to you soon.